minus 24 would be negative 27. And then this would be 5 and 5 would be 10, minus 26 would be negative 16. All right, so that is going to be a positive because it's negative over a negative. So it's going to be like positive, like 1.5-ish maybe. It doesn't have to be exact. All right, I know it's going to be more than 1, but less than 2, because 32 over 16 would be 2. So I'm just going to say it's around 1.5, and let's just plot that point on the graph. So I know it's definitely going to be above that asymptote. Okay, so that pretty much shows me what like I said, how it's going to look. There we have it. Kind of has an x cubed look to it there. All right. And then, so the domain is going to be everything other than the vertical asymptotes. So in this case, there are 2 of them. So it's going to be negative infinity to 1/5, union 1/5 to 5, union 5 to infinity. Okay. And then the range in this case is actually going to be all real numbers. Okay. Because of that middle piece. It doesn't have any, it's not skipping over the horizontal asymptote this time. Alrighty. Alright, well, and I can see now that we are already on part 2 of this video, because when I'm filming with my phone, if I go over 33 minutes, it'll automatically just starts a new video, which is what happened. I thought I was going to get through that one, but I didn't. Oh well. So now we're on part 2, part B. Alright, number 5. So we would set the denominator to 0 for the vertical asymptote. However, that's not going to have a real solution. You know, if you subtract 9 from both sides, you're going to have x squared equals negative 9. Take the square root of both sides. It would give you x equals plus or minus 3i, which is not real. So in this case, there's actually no vertical asymptote. For the horizontal asymptote, they do have the same degree. They both have a degree of 2. So divide coefficients, so basically 4 over 1, which is 4. So your horizontal asymptote is going to be y equals 4, which means you don't have any oblique. Okay. For x-intercepts, you would set the numerator equal to 0. Again, you would find it's no real solution. So there's no x-intercepts. Okay. For y-intercept, you plug in 0 for x. So 4 times 0 squared plus 25 over 0 squared plus 9. So that's 25 over 9, which is equal to 2 7/9. All right, so on the graph, we've got a horizontal asymptote at 4. All right, and then a y-intercept at 2 7/9. So that's just slightly under 3. So something like that. All right, and that's all the information we have to go on. So something like that. All right, so the domain is all real numbers. And the range, I'm not 100% sure about this, but don't worry about it, but I'm thinking, looks like maybe the lowest point is the 2 7/9, and then it definitely has an upper limit at 4 with the parentheses. So it's probably something like that. Okay, but don't worry about that for this one. All right. So number 6. Okay. So set the denominator equal to 0 to find the vertical asymptote. So if 4 minus x is equal to 0, then x would be equal to 4. For the horizontal asymptote, the degrees are the same. So that is exponents are the same, divide coefficients. All right, so, and make sure you do the leading coefficients. So it would be -3 over -1, which would just equal +3. So that would be y equals 3 is the horizontal asymptote. And since that exists, the oblique does not. To find x-intercept, set the numerator equal to 0. So I can just add 3x to both sides. 6 equals 3x. And then divide both sides by 3 would give me x equals 2. So 2 would be my x-intercept. And then to find the y-intercept, plug in 0 for x. 6 minus 3 times 0 over 4 minus 0. So that's 6 over 4, which reduces to 3 over 2, which is the same as 1.5. All right. So let's put all this on the graph. Vertical asymptote at 4. Horizontal asymptote at 3. X-intercept at 2. And y-intercept at 1.5. All right, looks good here. Okay, and then since we don't have any other x-intercepts, it's got to be up here. Okay, so domain is everything other than 4. So -infinity to 4, union 4 to infinity. And then range is everything other than 3. So -infinity to 3, union 3 to infinity. Okay. All right. Number 7. All right, so to find the vertical asymptote, we will set the denominator equal to 0. So that's going to require a factoring again. That's going to be x plus 2 and x plus 4. So your vertical asymptote is going to be x equals -2 and x equals -4. And then for horizontal asymptote, the degree on the bottom is 2. The degree on the top is 1. So that is big on bottom 0. So y equals 0 is going to be the horizontal asymptote. There's no oblique. For x-intercepts, we'll set the numerator equal to 0. So 2x plus 1 equals 0. Subtract 1 from both sides. 2x equals negative 1. Divide both sides by 2. So negative 1/2 is the x-intercept. And then for the y-intercept, plug in 0 for x. So 2 times 0 plus 1 over 0 squared plus 6 times 0 plus 8. So that equals 1/8. All right, and then let's just put all that on the graph. So we have 2 vertical asymptotes. One is at -2, the other one's at -4. And then the horizontal asymptote at 0, that's on the and then we have the x-intercept at -1/2. And then we have the y-intercept at +1/8. Okay, so we can see what's going on here. Okay. All right, now to figure out, we have 2 other sections here we have to figure out. So we could use a XY table. All right, so we need to use an x value from each section. So for the middle section, the best thing to do would be -3. So you have to plug -3 in for x in the function. So 2 times -3 plus 1 over -3 squared plus 6 times -3 plus 8. All right, so that would be -5. That's going to be 9 minus 18 would be -9, plus 8 would be -1. So that equals +5. So -3, +5. So right there. All right, so it's got to follow the asymptotes, and it can't cross the x-axis again, so it'll have to go up. So it kind of looks like a little mini parabola there. Okay, and then let's pick an x value over here, like -5, and plug that in same way. So 2 times -5 plus 1 over -5 squared plus 6 times -5 plus 8. So that's going to equal -9. And then that would be 25 minus 30, which would be -5 plus 8 makes it -3. So -9 over -3 equals +3. So -5, +3. All right, so that's above the axis, or yeah, also above the asymptote. So it looks like that. There's my graph. So my domain is everything other than my vertical asymptotes. So -infinity to -4, then -4 to -2, union -2 to infinity. And the range, again, it's a little bit hard to tell, but I'm thinking it's all real numbers in this case, because this is everything from 0 to infinity here. And then this is everything from negative infinity to 0, including 0 itself. So I'm pretty sure the range is going to just be all real numbers in this case. Again, I wouldn't worry about that. Okay. Okay, number 8. So find the vertical asymptote by setting the denominator equal to 0. So if x minus 4 equals 0, x equals 4. Horizontal asymptote, so the degree on top is 2, degree on the bottom is 1. So that would be big on top, that's botno. So big on top, none. So there is no horizontal asymptote, which means we probably have an oblique asymptote. The degree on top is only 1 higher than the degree on the bottom. So let's see here. So put the 4 in the box. And then the coefficients of the numerator would be 2, 0, 3, 2, 8. Okay, doesn't matter about the remainder. It's going to be y equals 2x plus 8. And I know sometimes I have a better graph, but right now this one is really small. It's not going to fit very well. So we'll see what we're going to do about that. Okay, let's go ahead and figure out the x-intercepts. Set the numerator equal to 0. It's not going to be any real answer to that, so there's not going to be any x-intercepts. And y-intercept, plug in 0 for x. So 2 times 0 squared plus 3 over 0 minus 4. So that's 3 over negative 4. So in other words, negative 3/4. Okay. I'm just going to go ahead and count by 4s, and hopefully that'll be good enough. 4, 8, this will be 4, 8, 12. Okay. Let's see. So then the vertical asymptote is at 4. And then the oblique asymptote has a y-intercept of 8 and a slope of 2. So up 2 over 1 or down 2 into the left 1. Yeah, it still really sucks. Oh well. We have a y-intercept there. So no x-intercepts, so it kind of looks like this. And then it's going to be way up here, really, somewhere. Can try to, it's going to go way up here in the middle of this other problem, but oh well. Maybe hopefully on my completed notes I have it looking a little bit better. I don't know. Okay, but anyway, the other part of it would be way up here. Something like this. Okay. Anyway, so domain is still going to be everything besides the vertical asymptote. So negative infinity to 4, union 4 to infinity. And then the range, we don't even know. So don't even worry about it. Okay. Alrighty. One more problem in this section. Number 9. Alright. So to find the vertical asymptote, set the denominator equal to 0. X squared minus 2x minus 15 equals 0. We can factor that. That would be x minus 5 times x plus 3 equals 0. So for your vertical asymptote, you would have x equals 5 and x equals negative 3. And then for your horizontal asymptote, the numerator and denominator both have a degree of 2. So that is exponents are the same, divide coefficients. And the coefficients in this case are 1, so 1 over 1. So y equals 1 would be the horizontal asymptote. So we don't have any oblique in this case. Okay. And let's see. X-intercepts. Set the numerator equal to 0. So x squared plus x minus 6 equals 0. So that'd be x minus 2 times x plus 3. So 2 and negative 3 would be your x-intercepts. And y-intercept, plug in 0 for x. So 0 squared plus 0 minus 6 over 0 squared minus 2 times 0 minus 15. So negative 6 over negative 15. The negatives cancel out. And then that's going to be 2/5. Okay, well, as you may or may not have noticed, we do have a conflict of interest here. You cannot have a vertical, you can never cross a vertical or touch a vertical asymptote. So you can't have a vertical asymptote and an x-intercept at the same value. Okay, so I'm just going to, all right, so what we do have is a hole. All right, so we do have a hole at where the x value is negative 3. All right, so let's look at our function. Let's basically write down our function in factored form. And when we've already factored both denominator and numerator, so when we factored the numerator, it was x minus 2 times x plus 3. And then when we factored the denominator, it was x minus 5 times x plus 3. Okay, so let's cancel this out. And then we just have x minus 2 over x minus 5. So if we wanted to figure out the y value of the whole, we could just plug in negative 3 for these x's now. So like negative 3 minus 2 over negative 3 minus 5. So that would end up with negative 5 over negative 8. The negatives cancel out, so that's 5/8. All right, so that gives us the coordinates for the whole right there. Okay, and now we're ready to graph. So we have a vertical asymptote at 5. And then we have a horizontal asymptote at 1. And then we have a x-intercept at 2 and a y-intercept at 2/5. We also have that hole at -3 and 5/8. Okay, and we can see it kind of goes, it's all, in line with that. It looks right. Okay. It's not a hole way over here or something. It looks right. It's in line with this. All right, and then we don't have any other x-intercepts or anything, so the other one would be up here because we can't cross the x-axis. All right, so our domain, we are excluding the 5, and we're also still excluding the -3 from the domain. So domain would be -infinity to -3, union -3 to 5, union 5 to infinity. And then the range is everything other than 1. So -infinity to 1, union 1 to infinity. All right, so the range would exclude the horizontal asymptote unless you pretty much know for sure, like we did on some of those other ones, that the it's going to cross that. Okay. All right, so that is it for chapter 3.